Hey friends! Okay, quick little video to explain where that power in the power series comes from. So this is the equation that you saw in sheets. I added the y equals because it always bugs me that it doesn't have the y equals there. I mean, this is what you're interested in. You're interested in the no stop time. And it's a function, as I circled here, of x, which is the depth that you're at. So if you plug in a depth, this equation, this formula, kicks out your no stop time based on your depth. Awesome. I just wanted to make sure that you made peace with the symbols, especially all this mess over here. This number right here, all that is, the 4543008, all that is it's, think of it as like a bend. That curve that you see there in the graph can be bent like this or bent up like this, depending on the value that's right there. It's also somewhat dependent on the value here. These two numbers work in tandem to kind of bend the curve to fit the points the best possible way. But ignore that one. It's just a factor is all it is. I wanted to make peace with this caret first because this really explains the power in the power series. So I'm going to write the x again. And then the caret is just old school signal line display from the 80s, meaning to the power of. So that really means take x and raise it to the power of negative 2.19. That's it. That's it. That's why it's called a power series, because the variable is raised to a power. That's simply it. I mean, not to put too fine a point on it, or too broad a point, I guess, too broad a brushstroke, but that's all it is. Negative 2.19 is the exponent, the power on the variable x. This is just a coefficient. Like again, that's just there as a factor, but the power is really there. If anybody's bugged about why it's negative 2.19, the quick and easy explanation is that's why the curve is dropping as it goes left to right. If that were a positive number, it would be rising. And if you're watching my hand right now saying, hey, that looks kind of like a parabola, that's because that number's very close to 2. Very, very close to 2. And parabolas are when that number is exactly 2. But nobody says the power has to be a whole number. As a matter of fact, with numbers like this, sometimes you have to dial them in with decimals like this one. And sometimes make them negative depending on which way the data is going. That's a quick introduction to what power series are and why they're called that way. Hope it helped. Go ahead and check out the next bit of the homework.